Those are the factors of the constant, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. For 1, the leading coefficient is just plus or minus 1. So the P over Q is basically just the list of the P factors. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. So remember, this means that of all the numbers on the number line, from negative infinity to infinity, these are the only 10 numbers that could possibly be rational zeros for this polynomial. Okay, the only ones. Now and I think I mentioned it before, whenever you have 4 terms, a cubic with 4 terms, I suggest you try to see if it factors by grouping. And the way I set it up is like in a 2x2 grid. If it works, fine. It cuts your work by a lot. If it doesn't work, then we'll proceed the other way, right? Where we try the P over Q factors. So the greatest common factor in this row right here is x squared. So you have x squared. Something times x squared is x cubed, that would be x. Something times x squared is negative 4x squared, that would be minus 4. And then something times x is negative 4x, so that would be minus 4. So negative 4 times negative 4 is 16, so that works. So what this means is that my factors are x minus 4 times quantity of x squared minus 4, and this is a difference of squares, so you could do x minus 4, and then this would be x plus 2 times quantity of x minus 2. So the zeros are 4 and plus or minus 2. Okay, so the factors of P are plus or minus 1, plus or minus 2. The factors for Q are going to be plus or minus 1, plus or minus 2, and plus or minus 4. And so you take all the P factors over the Q factors, and we get plus or minus 1, because 1 over 1. Then, again, I'm taking this one over each of these. Okay, so then it's going to be plus or minus 1/2, plus or minus 1/4. Then I move on to the 2. I'm going to take this 2 right here and put it over this number, and over this number. So 2 over 1 is 2. And then 2 over 2 is already there. We have it 1. And 2 over 4 is already there. We have a half. So these are the 8 numbers, right, because there's a plus or minus. These are the only 8 numbers on the whole number line that can be rational zeros for f of x. Okay, you could have irrational zeros, but rational zeros, these are the only ones that exist. So now, and you could also have imaginary zeros, right? But rational, there's only 8 on the list. Okay, so now we're going to try, I'm going to bring up the table for this graph and the graph for this function. So here you see 2 screenshots of the graphing calculator. The first one is the table for this polynomial, and the second one is the actual graph. So if you look at the table, we see that I have 1 0 right there, and I have 2 more zeros right here. And so they're at negative 1, 1, and 2. So if you look at your graph right here, let's see, this would be negative 1 right here, 1 right here, and then 2 right there. These in between ones, don't know if it's plus and minus 1/2. We'll find out right now. Or, yeah, it doesn't look like a fourth. It looks more like a half and negative a half, but we're not sure yet. So let's do the ones we know for sure, because we see it on the table right here that they give us the zeros. So I'm going to go ahead and do synthetic division with negative 1. So 4, negative 8, negative 5, 10, 1, and negative 2. So if we bring down the 4, negative 4, negative 12, multiply, you get 12, you get 7, minus 7, you get 3, negative 3, you get negative 2, and then 2, you get 0. Okay, so that one, we already knew it was going to work. So now I'll try 1. And remember, use the reduced polynomial. So 4, negative 12, 7, 3, negative 2. Bring down the 4, you get negative 8, you get negative 1, you get 2, and that gives you 0. Okay, so that one, of course, works. Then we'll go for 2. So again, use the reduced polynomial. So bring down the 4, you get 8, that's 0, negative 1, negative 2, and 0. Okay, so what does this mean? This means that I have 4x squared minus 1 is my factor, and this could be broken up into 2x plus 1 and 2x minus 1. Okay, and so x is plus or minus 1/2, so it was plus or minus 1/2. We got the confirmation here. And then the zeros would be, the other zeros would be plus and minus 1 and 2. So here are the 5 zeros.